Hello guys, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session we have started the rotational motion chapter. So where in that the first lecture, so we have discussed about different angular terms. So like what is angular displacement, angular velocity, angular acceleration, so tangential acceleration, radial acceleration, so net acceleration, so and angular uniform motion concept. So everything we discussed in the last session, right? So related to angular terms, and I also introduced the term called torque, right? So the torque is equals to R cross F. So we discussed about that. So in today's session, so that is lecture number 2, so we are going to extend the topic of torque. So how do you find the torque, net torque concept? So then how do we relate it to the static equilibrium? So what is actually static equilibrium and what is its relation with the torque? Okay, chal. So the questions related to the static equilibrium are very important for any competitive examination. Okay, clear guys? So I have some issue with my neck today, so I may not be able to rotate my neck, so at least 90 to 120 degrees also. So just so don't think that why sir is looking here and why he is moving head this side, that side. So don't think about that. So just concentrate on the lecture. So my humble request, so just for the next 1 hour, be with me, avoid all the disturbances around you guys. If you start the lecture, just finish it off in one stretch. Okay, clear? Chal. So and at the end of the lecture, it's very important to prepare your own short notes, guys. Clear? Chalo. So let's begin the today's lecture. So first, what is the net torque? So let's suppose, so on a body, if there are some different forces acting, so consider, so I'm taking this is a body. So now on this there are some different forces acting. Here the force F1 is acting, and here so the force F2 is acting. So here the force F3 is acting, let's suppose, and here some force F4 is acting. So on this block, so there are different forces acting. Now, so the torque will be there due to, let's suppose I have to find torque about this point. Let's say if I asked you to find the torque about this point, okay, X. So now the torque will be there due to the force F1. The torque will be there due to the force F2. So the torque will be there due to the force F3. F3 into its perpendicular distance, F2 into its perpendicular distance, F1 into its perpendicular distance, and torque will be there due to F4 also. So F4 into its perpendicular distance. Yes or no? So now, so then what is the net torque, sir? How do you find the torque due to all the forces we can find? So now what is the net torque, sir? So the net torque will be equals to, it's simply the vector sum of the individual torques. So let's suppose here 4 torques are acting due to 4 forces, 4 torques, right? So T1, tau 1, tau 2, tau 3 plus tau 4. So if n forces are acting on a block, so if n forces acts, if n forces acting, so then we can say that the net torque will be equals to, the tau net is equals to, so the vector sum of the individual torques. So tau 1, tau 2, tau 3, and then till tau n. So till tau n. Clear? Understood, guys? And so one more important thing here. So sir, the sign is also important, right? Because it's a vector sum. So the sign is also important. So for the sign convention, so follow this method. So the torque due to anti-clockwise, the anti-clockwise torque, take it as positive, and the clockwise torque, take it as negative. The anti-clockwise torque, take it as positive, and clockwise torque, take it as negative. Clear, guys? Understood this part? Chalo. So let's go further. Let's move further. So we'll solve the question so that you'll understand how do we apply the torque on the different bodies and if the different forces act at different places. So let's take the question number 1. So see here, forces are applied on a wheel of radius 20 centimeters. So this wheel has radius 20 centimeters, fine, as shown in the figure. So the torque produced by the forces 4 newtons here, 8 newtons here, and 6 newtons here, and then 9 newtons here. So we have to find torque due to all these 4 forces. So chalo, so let me take the next slide. So here the net torque, first thing is the solution. We need the torque. So the net torque. So the net torque will be due to, so the torque due to 4 newtons force plus the torque due to 8 newtons force plus, so the torque due to 6 newtons force plus the torque due to 9 newtons force, right? So then see here, see. So shall I say that, so we need the torque, let's find the torque about the center of mass due to all these forces. Okay, so torque due to the torque at the center, net torque at the center. So shall I say that the 6 newtons force is acting through the center? So yes or no? So if it is passing through axis of rotation, if any force is passing through axis of rotation, so the torque due to it will be 0. Yes or no? So shall I directly say that the torque due to 6 newtons force is 0. Now we need torque due to, so these forces. So first the torque due to 4 newtons force. So the force is this side, and what is the perpendicular distance? This is the tangential force, right? Here is the tangential force, it's a tangent. So and then this radius will be the perpendicular, radius and tangent will be perpendicular. So we know that, so the torque is equals to R cross F, either R into the perpendicular force, or we can write force into the perpendicular distance. Yes or no? So now shall I say that here the force is 4 newtons into the perpendicular distance further is, you can write what's that, 20 centimeters. So first let's write in, just write the value, at the end we will convert it to meters. So 4 into 20. So first thing is, this torque is clockwise or anti-clockwise. So due to this force, obviously the torque will be this side. So this will be anti-clockwise. So it will be positive, right? And then, so next, 8 newtons force. Come to the 8 newtons force. See, this is the radius. This is the radius. And then, so the force is not perpendicular to the radius here. The force is, see here, this is the force direction. So I need the perpendicular force. So this will be the perpendicular force. See, actually this is the 8 newtons force. You extend that. 8 newtons force is like this. So the force will have 2 components. So this will be the perpendicular component of force. So I can say that this will be 8 sine 30. Yes or no? If this angle is 30 degrees, so the perpendicular component of this force will be 8 sine 30. Yes or no? So then, so the what will be the force? The force is acting this direction. So the perpendicular force. So due to which, so the torque will be clockwise. So I can write the second one minus. So what is the force? The perpendicular force, 8 sine 30. See, you simply remember one thing. So either distance into perpendicular component of force, or force into perpendicular component of distance. Here force and perpendicular component, the distance, perpendicular distance. So but here perpendicular component of force into the distance r, right? So as it is producing the clockwise torque, so it's going to be negative. So 8 sine 30 is the force into, so what's the distance again? The radius. However, due to 6 newtons it's 0, and due to 9 newtons, see here, due to 9 newtons the torque will be like this. So as it is anti-clockwise, this is this is clockwise, so this will be negative again. So this will be, this torque is again negative, right? So then what is the force? 9 into, so what's the distance? 20. Yes or no? So however the angle is 90, sine 90 is 1. You can write RF sine theta also. Already the radius and the force are perpendicular, so which means the sine 90 value is 1, right? So here you can also write RF sine theta. So here you know the angle R, force and F. So the angle is going to be 90 degrees. So here also RF sine 90 is 1, right? So chalo, so the net torque will be equals to now, so this is 80 minus, so this sine 30 is 1 by 2. So 1 by 2, so 4 into 80. So minus, this is going to be 180. Yes or no? So 80 cancel. So the net torque is minus 180. So options are in centimeters or meters. So it is in Newton meters. So here this is Newton centimeters, because this 20 is in centimeter, right? So from here, so minus 180 by 100 Newton meter. So which means that minus 1.8 Newton meter. So what is this minus indicate? So minus means, so the net torque is clockwise. So 1.8 Newton meter clockwise is the net torque. Okay na? Clear guys? So 1.8, so option 2 is the correct one. So 1.8 Newton meters clockwise. Clear? Understood? Chal. Done? Chal. Let's move further. So let's go for the next question number 2. So let's try this question on your own guys. So find the net torque. So we have to find the net torque on the wheel about the point O. So about the point O, about the center point O. If A is equals to 10 centimeters, the inner circle radius is 10 centimeter and the outer circle radius is, the B is 25 centimeters. So again easy question. So how many forces are there? First, 1 force, 2, 3. So any force is passing through the center first. So no force is passing through the center here. Any force is not passing through the center. So the torque will be there due to all these 3 forces. So the first thing, so the net torque I can write here. So the net torque, so the net torque will be equals to the torque due to, so let's start with the 10 newtons. So the torque due to 10 newtons force, and the torque due to 9 newtons force, and the torque due to 12 newtons force, right? So first let's calculate the torque due to 9 newton, which one? 10 newtons force. So see, the distance from center to the 10 outer circle, it is how much from here to here? 25 centimeters, right? So it's a radius B, which is nothing but, sorry, radius B, which is 25 centimeters. So this is 25 centimeters, and the force is this side and the distance is this side. So that means already the perpendicular distance, or else you can take this angle as 90 degrees. So RF sin 90. So here, and what torque it produces? It produces the clockwise torque. Yes or no? So then I can say that, so the force is 10. The force is 10 into the distance is 25 centimeters. First let's write in centimeters. At the end we'll convert the total answer to meters. So sin 90 I am not writing, and as it is clockwise, so it will be minus, right? So this is done. So now let's go for the 9 newtons force. So 9 newtons force also will cause a clockwise torque. So this also causes the clockwise torque. Yes or no? So here again minus, force is 9 into, so about the center we required from here to here, again what is the distance? So 25. So 9 into 25. So again it is minus. So the angle is, the force and the distance are already perpendicular. This is also done. And so see here, so what about this force? What about this force? So this is 12 newtons. So but I need, this is the perpendicular distance, I need the perpendicular force. What will be the perpendicular force? So this will be the perpendicular force. So if this angle is 60 degrees, this is a force 12. So this is going to be 12 cos 60 degrees. 12 cos 60 degrees. So 12 into cos 60 degrees is what? So 1 by 2. So which is nothing but, so 6 newtons is the force, the perpendicular force. So and which torque it produces? See here, which torque it produces? The clockwise torque. So the, yes or no? So this force produces the clockwise torque. So clockwise or anti-clockwise? This is anti-clockwise, sorry, anti-clockwise, right? So this is anti-clockwise, so this is clockwise, and this is also clockwise. So now see here, so this will be positive. So what's the force? The perpendicular component of the force 6. And what is the distance? The perpendicular distance. See, the force is acting here. So what is the perpendicular distance? The inner circle radius A you have to take. So what is the inner circle radius? 10 centimeters. So let's take this as 10. Hope you guys are understanding now. So this is minus 250 and then minus 225. Yes. So plus 60. So what will be the total answer? So here we can write so 250, 500. So 500 minus 475 plus 60. right? So from here minus 415 Newton centimeters. So check the options. So it is in centimeters or meters. So it is in meters. So convert it to Newton meters. So here by 100. Yes or no? So which is nothing but minus 4.15 Newton meters. So minus 4.15. What is this minus indicate? So minus indicates so the net torque is clockwise. So the net torque is clockwise. See here 4.15 meters clockwise. Newton meter clockwise. Understood guys? Clear? Everyone? Done? Chalo. So let's move further. Let's go for the next question or topic. So the topic, see here. Now let's come to the topic, what is static equilibrium. So till now we discussed about so the translational equilibrium. So if the net force acting on the body is 0, so net force acting on the body is 0 means, so the summation of forces in the x direction should be 0. So the summation of forces in the y direction should be 0, and the summation of forces in the z direction should be 0. So this is a net force acting on the body is 0. If the net force acting on the body is 0, so we already studied in the motion of system of particles that so the acceleration of center of mass will be equals to 0, and then velocity of center of mass will be equals to constant. Velocity of center of mass will be constant. So a body is said to be in translational equilibrium, so when the net force acting on the body is 0. Similarly, so a body will be said to in rotational equilibrium. So in the linear terms, whatever the role the force plays, in the angular case, so the same role the torque will play. Okay. So when a body is said to be in rotational equilibrium, now whenever the net torque acting on the body is 0. So if the net torque acting on the body is 0, so then we can say that here acceleration became 0. So here what is the acceleration equivalent term? So angular acceleration, which is alpha. So alpha will be 0. And then what will be, which velocity will be constant? So the angular velocity will be constant. That's it. Okay. So this is the concept you should understand, guys. So a body is said to be in static equilibrium. So if it is in translational equilibrium and as well as rotational equilibrium. If a body is in both translational and rotational equilibrium, so then it is said to be in static equilibrium. So static equilibrium means, again I am writing, so static equilibrium, a body is said to be in static equilibrium. So when, so the F net is 0, the net force acting on the body is 0, and the net torque acting on the body is 0. So net torque acting on the body is 0. So in these two cases we can say, so the body is said to be in translational equilibrium. Clear guys? Understood the concept? Chalo. So let's move further. So the torque about any point, is 0. So under static equilibrium, so understand this point guys, very important. So for the next 1 hour or next whatever the questions that I am going to solve, so they will be completely based on the static equilibrium. Under static equilibrium, so you can say that, so the net force will be 0. The first point you can consider, the net force will be 0, and then net torque also will be 0. Net force will be 0, net torque is 0. So now torque about which point we should take it 0, sir? Whether it is about the center of mass or any other point of the body. So remember, if the body is in static equilibrium, the torque about any point is 0. So the torque about any point is 0. So different questions I am going to take. So in different questions I will take about the different points the torque is equals to 0 and I will get the answer. Okay, you can observe that guys. So now see here, see, so the torque about any point is 0. So that means, so the net torque should be equals to 0. So which is nothing but, so the torque about clockwise must be equals to the torque about anti-clockwise. Yes or no? So if the net torque is 0 means, so the torque will be either clockwise or anti-clockwise, because the torque, if the torque is acting means body is rotating. So body can rotate either clockwise or anti-clockwise. If the net torque is 0 means, so the clockwise torque is equals to anti-clockwise torque. Okay, so this point you remember, guys. Till now you have solved the questions which are based on the net force acting on the body is 0. When the body is in translational equilibrium only, so we take net force is 0. If the body is in static equilibrium, we should consider both the forces is 0. Which forces? One is the translational, which is net force 0, and the other one is the net torque is also 0. So then it is said to be in rotational equilibrium and translational combinedly static equilibrium. Clear? Done? Chalo. Now let's take a simple question. So 4 equal and parallel forces are acting on a rod as shown in the figure at distances 20 centimeters, 40 centimeters, 60, 80. So about this point here, 20 centimeters, one force is acting. At a distance 40 centimeter, one more force is acting. At 60 centimeters, one more force, and at 80 centimeters, one more force is acting. So from one end of the rod. So under the influence of these forces, so the rod will. So the rod is at rest. So that means will it be at static equilibrium? So if it is static equilibrium, so it will be at rest because no translation, no net force and no net torque. So and then experiences a torque. So that means torque is not equals to 0. Experiences a linear motion. So that means F net is not equals to 0. So experiences a torque and also a linear motion. That means torque is not equals to 0 and F net is also not equals to 0. First see that they said 4 equal and parallel forces. So one force is acting this side and another force is this side. So shall I say that these two forces will get cancelled? Yes. So and then one force is acting this side and another force is acting. They are all of same magnitude. So that's why this force gets cancelled and this one gets cancelled. So I can directly write like, so the first thing, so the net force is 0. So the net force acting on the body is 0. So that means, so the body will have no linear motion. So the linear motion of the body will be 0. So that means it is at rest. So it can be. So it experiences a torque. So we did not decide it. So it experiences a linear motion. This option you can rule it out. So it experiences a torque and also a linear motion. So linear motion is not there. So you can rule out this option also. Now we have only two options. So one is whether it is at rest or experiences a torque. So if you find the torque, so then you'll get to know. So how do we find the torque now? So how do we find the torque? So see here, let's find the torque. Now, so let's find the net torque. The net torque. So here the torque will be due to 4 forces. So let me consider this is a axis of rotation, or about this point I am going to find the torque. So the torque about point O I am finding. You can take any point, guys, your wish. So the torque about any point you can take. Okay. So but this will be easy because from here I know this force distance and this force distance and this force distance and this force distance, right? So and here one thing that plays important role is, so whether the torque is whether the force is causing a clockwise torque or anti-clockwise torque. So identifying it is a very important thing. So how do we identify, sir? So just follow this simple trick. So here this is your point. About this point you are finding the torque. So now just imagine this is a rod. So this is the rod. About this point you are finding the torque. So now here the first force is acting downwards. Just imagine you are pulling it here. You are attaching a rope here, and then you tied a rope here, and then you are pulling it downward. So that means the force is acting downward. So if you pull it downward, so this rod will move this side. Yes or no? So this rod will move this side. Yes or no? It rotates like this. If you pull it downward, so that means it causing a torque this side. Yes or no? So this force is causing a torque this side. So what is this torque? So this is a clockwise torque. Yes or no? So the first thing is clear. So now what is the torque due to this force? So now just imagine. So just imagine this one. Here you tied a rope. Now at this point you tied a rope. So then you are pulling it upward. So if you are pulling it upward, so the rod will move in this direction from horizontal position to this side. So that means, so in which direction the torque is acting? See, if it is moving this side means the torque is acting that side. So here the torque will be this side. Yes. So and then, so what about this force? Again imagine, so here you tied the rope now, so then you are pulling it downward. The force is downward means you are pulling it downward, so the rod will bend this side, so that means the torque is this side. So this is clockwise, so this is clockwise, and this is anti-clockwise. And what about this force? So and again at the end you are tied a rope, and then you are pulling it upward. So if you are pulling it upward, so then what happens? So the rod will move like this, so that means it causes a which torque? The clockwise, anti-clockwise torque, right? So now let's find the total torque. Let's find the total torque. So the torque about point O is, first the force is F. The first one is, this is the first one I am talking about, and this is the second one, this is the third one, this is the fourth one, because all the forces are same magnitude, right? So first one is clockwise, so negative torque minus what is the force? F into what is the perpendicular distance from here to here? 20. Here they say 20, so 20 centimeters, let it be in centimeters only. So fine. So next one, second force is anti-clockwise, second torque is anti-clockwise, so positive. So what is the force? Again F into what is the distance from here to here? This is your about this point you are finding the torque, that means this distance you have to measure 40. And then next this one guys, about this from here to here 60, and force is acting downward, distance and force are perpendicular, and which torque it is? Clockwise, so negative, F into the distance 60. And the fourth one, so from here to here the distance 80, and which force is acting? F force, so the distance force are perpendicular, so which torque? Anti-clockwise, so positive, so F into 80. So now you can write like simply, so minus 20F, so minus 60F, so let's write all the minus at one place, and then this is 40F, so this is 80F, this is 40F, and this is 80F, yes or no? So then this is minus 80F, and this is plus 120F. So overall the net torque is, so 40F. So that means, so I can say that the torque about O, which is the net torque, is not equals to 0. So if the net torque is not equals to 0, so we cannot say it is at rest, right? Why? Because so the net torque is not 0. The net torque is not 0 means it will rotate, yes or no? It will rotate. So in which direction it rotates, sir? It rotates, because we got it positive, so it rotates anti-clockwise. Overall it rotates anti-clockwise, yes or no? So that's why rest is wrong option. It experiences a torque, some torque it experiences. So if you know the force magnitude, you can find the torque also, yes or no? So the net torque is, so anti-clockwise, as it is positive, so the net torque is anti-clockwise. Clear guys? Understood the concept now? Done? Chalo. So let's move further. So now let's take one more question. So what's the question says here? Two small kids weighing 10 kg and 15 kg respectively are trying to balance a seesaw of total length 5 meters. So with the fulcrum at the center. So see here, this is a seesaw. Seesaw is nothing but the one which the kids play at the parks, right? So that's a seesaw. So this is the fulcrum. Let's consider this is a fulcrum, so which is exactly at the center. So what's the total distance? This total distance is 5 meters, right? So the total seesaw distance is 5 meters. If it is exactly at the center, so this distance is 2.5, and this distance should be, right side distance should be 2.5. Yes or no? Or else let's so if it is 2.5, automatically that will be 2.5. So now what they said, if one of the kids is sitting at an end, so two kids are there, let's suppose one kid is sitting at one end, so other sit where he should sit. So where should the other sit with respect to the fulcrum? So from the fulcrum, so what is the other kid's distance? So let's say, so from fulcrum, so the second kid is sitting at a distance x. So the first kid, let's suppose his weight is 10 kg, and then so the second kid, his mass is 15 kg. Here this guy is having mass 15 kg. So now you can simply do the question. So I can take, so because when these two kids are sitting, so they will be balanced, yes or no? So they both will be balanced. So otherwise it will rotate. If it is not balanced, it will rotate. Yes or no? So that means, so the net torque should be 0. Yes or no? So shall I say, so the net torque should be equals to 0, or else let's see this one. So the torque about any one point you consider 0. So either this point, or you take about this point, or you take about this point. Okay, so now what I am doing is, so the simple thing, so let me take, so the torque about fulcrum is 0, because we need this distance, right? So the torque about this fulcrum is 0. So or else the torque about center is equals to 0, whatever, or let this point be O. So the torque about O is 0. Okay, so then here, which force causes the torque which side? So this person is of weight, so this person is of weight 10 G, and then this person is of weight 15 G. Now just imagine, so with respect to this point, if you pull the, like just imagine here we are applying the 10 G force. So if you pull it downside, so it causes a torque like this. So anti-clockwise, about this point you imagine, here is the point of rotation. So now you are applying the force here. Here is the point of rotation. You are applying the force this side. So then it is rotating this one this side. So that means anti-clockwise. Now just imagine what about this. So this is a point of rotation now. So this is a point of rotation. Just imagine like this. This is a point of rotation. Now you tied a rope here and you are applying the force. 15 G force you are applying. So this will be clockwise. This will cause, so the clockwise torque. So as the net torque is 0 about the fulcrum, so I can say that, so the torque due to anti-clockwise will be equals to the torque due to clockwise, right? So here, what is a anti-clockwise torque? So the force into the perpendicular distance. What is the force? What's the force? 10 G is the force into what is the perpendicular distance from here to here? So 2.5. So which is equals to, so what about the clockwise? So we can take the force is 15 G into what is the distance from fulcrum? You have to take from the point of from which point you are, about which point you are taking the torque is 0. So about this fulcrum, right? So from here you have to measure the distances. So from here to here the distance is x, right? So then 10 G, so here G cancel. So I can write, so 5 2s are 5 3s are, right? So then this comes out to be, so 5 is equals to 3 into x. So then x is equals to 5 by 3, which is nothing but 1 point. So 20 means 1.20 16 18. So again 20 1.666 like that. So which is nothing but the closest option is 1.67 meters approximately. Option 3 is the correct one, guys. Understood? Clear? Done? Done, guys? Chalo. So let's go for the next question. So let's take one more question. So the question number 5. So first read the question. What's the question says? A uniform rod of 20 kg is hanging in horizontal position with the help of 2 threads. So this is a 20 kg rod which is hanging from here. So this is the total 20 kg rod. So fine. So it also supports 40 kg mass as shown in the figure. So again 40 kg mass is attached to it. So the tensions developed in the threads are, so what are the tensions developed in the threads? Okay. So the first thing, so here the tension will be this side T1 away from the point of contact. Here let the tension be T2. So because these two strings are different, here the string is different and here the string is different. So the T1 and T2. So now this is a 20 kg block. So 20 kg rod. So where this 20 kg will act? So the total 20 kg. So its weight 20 G will act at the center of mass. Yes or no? Where this total mass lies? At the center of mass, right? So the total weight will be 20 G from where? Its center of mass. So now, so and again here a force is from here. What is this? 40 kg, which is nothing but 40 G. So now let's take, so the net force is equals to 0. So the F net is equals to 0. let's take first. So the F net is equals to 0. So what are all the forces that are acting on the body? So the tension force is acting up here, and the tension force is acting up, and 20G is acting down, and 40G is acting down. So shall I say that, so the T1 plus T2 is equals to 20G plus 40G. See, just understand the question, guys. So T1 plus T2, we got it as 60G, let it be. First I consider the body is in translational equilibrium, because it is at rest, right? So the body is at rest. Clear? So then we can consider the net force acting on the body is 0. So what are the net forces? T1 plus T2 is equals to 60G. Here 40G and here 20G. So this is fine. Next, let's come to, so the net torque is equals to 0. So it is hanging in a horizontal position. So it's not rotating. So that means, can we take, so the torque about any point is 0. So the torque about which point we'll consider? So let me take, so here, this is the total weight. So this is 20G acts here. So and what are the other forces that are acting? About this point, about this point. So about this point, here tension T1 is acting. So here 40G is acting, right? So and then here T2 is acting. First, which force causes torque which side? So that you should understand. So the first thing is, so the torque due to the tension T1 is 0. So first let me write. So the torque about point A I am finding. The torque about point A I am finding. So why? Because, so it will be simple. I know the distance from here to here, and I know the distance from here to here. So what will be this distance? This distance will be total L by 2. This is L by 4. The total length is L. The center of mass will be exactly at the center, right? So this distance will be L by 2, obviously. Yes or no? So from here to here, the distance will be, the T2 will be at a distance of L. The total rod length is L. So now I am taking the torque about A. So therefore the torque due to tension T1 plus, so the torque due to 40G. Just I am writing what are all the torques that can act because of all the forces. So and then the torque due to 20G, and then the torque due to T2. So these are all the possible torques. So now the torque due to T1 I can take it 0. Why, tell me? Because this force is passing through the axis of rotation. This is your point of reference. About this point only you are finding the torque. So it is passing through the axis of rotation, which means, so the torque due to T1 is 0. And so torque due to 40G will be there, 20G will be there, T2 will be there, obviously. Now which one is causing the torque which side? So that's important point. So now you take this as a point of, this is your axis of rotation. This point is a fixed point here. About this you are finding the torque. So now 40G is down. See here, imagine here you tied a rope. So and you are applying a 40G force. What happens? So this rod will move this side due to the 40G. So it causing a anti-clockwise torque. It causing anti-clockwise, clockwise. So clockwise torque. Clockwise torque, right? So and then, so what about this one? So 20G again at some distance you applied. So the 20G force again downside like this. This is your axis of rotation. So here you are applying the 20 newtons force, 20G force. So again the rod will rotate this side. So this is again clockwise. Now, so again this is your axis of rotation. From there, so the T2 force, here the T2 force, which side you are applying? Upside. So that means, imagine just you tied a rope at the end and you are pulling it upside with some T2 force. So then the rod will move upside due to that force. So that means here it's causing a anti-clockwise torque. It causing a anti-clockwise torque. Yes or no? So now I can say that, so the torque about the point A should be equals to 0. So from here, so the torque about 40G. What is the torque about 40G? The force is 40 into G. The torque about this point I am taking it as 0. The torque about any point you can take it 0. So I am taking torque about point A is 0. So it is causing a clockwise torque. So let's take, so minus 40G, and then, so this is what is this? Minus 40G into L by 4, sorry. Minus 40G is acting at a distance L by 4. So and again minus, this is also clockwise, right? So what is the force? 20G at a distance L by 2. Fine. So plus the last one T2 which is at a distance L. T2 which is at a distance L. So from here I can write, so let's bring T2 into L is equals to 40G into L by 4 plus 20, just I am bringing these two to this side. So 20G into L by 2. Yes, so from here L gets cancelled. So from here 4 ones are 4 tens are. So here 2 ones are 2 tens are. Right. So T2 is equals to, I can write 10G plus 10G. So which is 20G. So that means T2 I got it as 10G means 20G means 20 into 10 which is 200 newtons. So I got the tension T2. Now, so what is our requirement? We need the tensions developed in the threads R. So total T1, T2 we required. So here we already have the equation. So simply, so the T1 plus T2 is equals to 60G. T1, so T2 we just now we got. So what is that? 20G. So T2 in place of this 20G you can write, which is 60G. So from here T1 is equals to 40G. So which is nothing but, yes or no? So 20 minus this is 400. Yes. So T1 is equals to 400. T2 is equals to 200. T1 400. T2 200. Option 2 is the correct one, guys. Understood the concept, everyone? Done? Sure. So let's take one more question. Let's take one more question. So if the mass of the rod is 10 kg, find the normal reactions of the supports. So here is one support and here is one support. So this is a 10 kg rod. So 10 kg rod, it weight acts 10G downside. First represent all the forces acting on the body. This is the rod of mass 10 kg which is of length 10 centimeters. Right. So this rod is supported by two supports. Here is one support and here is one support. So which is from one end it is at a distance 2 centimeters. From the other end it is at a distance from this end it is at a distance 7 centimeters. Fine. So now, so I can say that this distance will be from here to here. This distance will be 3 centimeters. And if it is 2 plus 3, 5. So this distance will be all obviously 2 centimeters again. Because it is exactly the center. Yes or no? So no. So next what I required, so find the normal reactions. So here support is there, so normal will act upside N1. So we need two normals. So here also the support is there, so the normal will act upside. So first I can say that the simple thing, so the net force acting on the body is 0. Yes or no? So if the net force acting on the body is 0, so the N1 plus N2 should be balanced by N1 and N2 should be balanced by 10G. N1 and N2 should be balanced by 10G weight. Yes or no? So now this is, let it be the equation number 1. So the second thing, so I need the torque about any one point. So let's take in the next slide. So the torque about which point we can we take 0? So we need N1 and N2. So let's make any N1 or N2 0. So let's find the torque about this point. So let this point be A. So this is the center at which, so the 10G force is acting, and here the normal N2 is acting, and here the normal N1 is acting. Yes or no? So and this distance will be 3 centimeters because this is exactly at the center. So this distance should be 3 centimeters because total is 10. So till here it is 5. So it's already given 2. So this will be 3. So then this also should be equals to what? So this total thing is 7. From here to here 5 means this should be 2 centimeters. Yes or no? So now I am taking the torque about point A is equals to 0. Torque about this point A is equals to 0 because N1 will become 0. Then I will get N2 directly. Just choose the point logically. If I take about this point, again N1 equation will come, N2 equation will come, calculations will become lengthy. So if I take about this support, first support, so the torque due to N1 will become 0 because that force is passing through your axis of rotation. Yes or no? So that's why, so I am taking the torque about A is 0. So first, so the torque about A, what are all the torques that we have? The torque due to N1 plus next we have the torque due to 10G force, and next the torque due to N2 should be equals to 0. should be, yes or no? So the torque about point A. So due to N1 force, due to 10G force, due to N2 force, that's it. So all equals to 0. So the torque due to N1 is already 0 because it is passing through axis of rotation. So what will be the torque due to 10G? So 10G. So first just imagine this is the axis of rotation. That means consider this as a support. Now you are pulling it here. So you are pulling downward. You are pulling it downward, 10G force. So this causes, so the clockwise torque, the 10G force causes the clockwise torque. And what about the N2? So just imagine here is the axis of rotation and you are applying N2 force upside. So you are pulling it. Just imagine you tied a thread or rope and you are pulling it upward. So the rod moves this side. So that means it causes a anti-clockwise torque. Yes or no, guys? So now simply, so you can substitute here. So the torque due to 10G will be negative of, so because clockwise. So force is 10G into, so what is the distance from here to here? So this is your point. So from here you should take, don't consider phi, because this is your axis of rotation. About this point you are finding. So that's why 3 centimeters. So consider this is 3 centimeters. So the torque due to N2 is plus. Why? Because that is the anti-clockwise. And N2 into, so from this point it is at a distance of what? About this point, don't consider from the center. So from this point, what is the N2 distance? So from here to here it is 3 and here to here it is 2. So total 5 centimeters. So into 5 is equals to 0. So I can write here. So 5 into N2 is equals to 10G into 3. Yes. So from here, so I can write N2. So this is 2. So N2 is equals to 6G. Yes. So I got N2 6G means this is 60 newtons. So the N2 normal reaction N2 is 60 newtons. So we already got what is N1 plus N2. So from here, so I can write N1 plus N2 is equals to 10G, right? So N1 plus N2 is equals to 10G. From here already we got what is N2. So N2 is 60G, which is 10G. So here, so N1 is equals to, so send it to that side, so 50G. Yes or no? So 50 newtons. Sorry guys, some calculation mistake I guess. 50 newtons and 60. 50-60 is not there. 20-80. So let me check the calculations, guys. So the torque about point A is 0. So this is from here to here. The distance will be 3. So the torque due to 10G into, so this causes the clockwise torque. So minus 10G into 3. So this is clockwise torque. So from here to here it is 3 and from here to here it is 2. Yes or no? So this total is 7, right? So from here to here it is 2. So this is 3, 5. So here to here it should be 2 only. Yeah. So N2 into, sorry, here I did the calculation mistake. My bad. Sorry guys. Here N2 into 2, right? N2 into, see here, from this point, so 2 plus 3, 5 only, correct? About this point only, right? So into 5 is equals to 0 due to N2. So then here we got, so this is, let me do it again. 5N2 is equals to 10G into 3. 5N2 is equals to 10G into 3. So 5 ones are 5 twos are. So 2 into G, 6G. So N2 is 6G we got. So then N1 plus N2 is equals to 10G only, na? Its weight is 10 kg, so 10G only. So 10G means 100. So let's write, see here, yes, correct only we got. Sorry guys, my bad. So N1 plus N2 is equals to 10G means what? 100, right? So from here N1 plus N2 we got 60, right? So 100. So from here N1 is equals to 100 minus 60, which is 40 newtons. So that means N1 is 40, N2 is 60. N1 is 40, N2 is 6G means 60 you can write. Sorry, my bad. Correct only. So 60 and 40 newtons. Clear? Option 3 is a correct one. Done? So now next. So let's go for the next question. So the question number 7. So what's the question says here? So what's the question says? A rod of weight W is supported by two parallel knife edges A and B is in the equilibrium in a horizontal position. So this is a rod. So consider this is a rod. So which is supported by two parallel knife edges. So consider this is one edge and this is one more edge. A and B is in equilibrium. So its weight is, weight will be at the center, W. Fine. So the knives are at a distance D from each other. So the distance between them is D. So two knives are at a distance D. So the center of mass of the rod is at a distance X from A. So the center of mass of the rod is at a distance X from A. Let's consider this is A point. So from here to here, if it is X, from here to here if it is X, so this will be obviously D minus X. This distance will be D minus X, guys. So then, find the normal reaction on A. We have to find the normal reaction on A we required. So the first thing, so just draw the free body diagram. We can take it is in horizontal position. So directly you can consider the torque about any point is 0. So here let the normal reaction N1 and here let the normal reaction N2. Okay, so this is point A, this is point B. So I need the normal reaction about point A. So let me take, so the torque about point B is equals to 0. So let's take the torque about point B is equals to 0. So then, so what are all the, with respect to this point you imagine now, with respect to this point, so what are all the forces? N2 force, W force and N1 force are acting. So this is your axis of rotation now. This side axis of rotation is there. So now the torque due to N2 will be obviously 0. Obviously 0. So the torque due to N2 will be there and torque due to W will be there and torque due to N1 will be there. So all these should be 0. Now, so N2 is however 0. You can take it as 0. So from this point, if you are pulling it downwards, see here. Here, this is your axis of rotation. So W is acting. Here you tied a rope, let's suppose. You are pulling it downwards. So the rod will move this side. So that means this W causes a torque this side. Right? So what is this one? Anti-clockwise. So now this is your axis of rotation. What about N1? N1, you are pulling it upwards. So N1, you are pulling, see here. This is your axis of rotation now. Wherever you are choosing the point, about that point I am taking the torque 0. So that means that is the axis of rotation. So now N1 is acting here. So which side? Upside. So just imagine there is a rope connected here and you are pulling it upwards. So then it causes the rod to move this side. So which means it's causing a torque this side. It's causing a torque this side. So what is this torque? So this is a clockwise torque and this is a anti-clockwise torque. So I can write, so the torque due to weight W. So the force is the torque due to, so this is anti-clockwise, right? So positive. So W into, so what is this distance from here to here? From here to here the distance is D minus X is equals to, so or else you can write it as minus, this is 1, and so the torque due to N1 from here to here, the torque due to N1 which is negative because this is clockwise, right? So what is the force? N1 into, so from here to here what is the distance total? D distance. From here to here what is the distance? D distance. So this should be equals to 0. So from here N1 into D is equals to W into D minus X. W into D minus X. We need N1. So N1 is equals to W into D minus X by W into D minus X by D. Yes or no? So W into D minus X by D. So option D is the correct. Option 4 is the correct one. Clear, guys? Understood the concept? So this is about the torque and static equilibrium. So I am giving some questions as homework. 4 questions I will give the homework. So try to solve this question, guys. So this is homework 1. And then, so this is the question, homework 2. If you are not getting, I will solve it in the next session. Homework 2. And this is homework 3. And then, so this is the ladder problems. We'll discuss only 3 homework questions. Ladder problems we'll discuss it in the next session. Okay. So chalo, guys. So I'm winding up the class here. So in the next session we'll deal with the ladder problems and I'll introduce what is moment of inertia. So till then, keep studying. All the very best. Bye. Take care.